In this video I'm looking at the solution to question 1 from the January 2011 Edexcel D1 paper. The question starts by showing us a network of roads between 8 villages from A to H, and the number of arcs, the number in each arc gives the length in miles of the corresponding road. We're asked to use Dijkstra's algorithm to find the shortest distance from A to H, in part B to state our shortest route, and then finally to write down the shortest route from H to C and state its length. So in the answer booklet there is a standard sort of table for Dijkstra's algorithm where we put in the temporary labels on each of the points starting at A, and then to try and find what the shortest route from any point from A. So the method works as follows. We start off at A, putting in a temporary label 0 at that point. Well, of course, that one then becomes the first point to be labelled. So this is the order of labelling, and it's given the value 0. From A, we then look at all other points that can be reached from that one, the point which was last labelled, and put in temporary values. So from A to B, well, that would give us a value of 4. From A to C, we have 9, and from A to E, 14. Look at all of the points which have got these temporary labels on and find the smallest of those, which happens to be B. So this becomes the second point to be labelled and is given its value 4. Working from B, the last point that was labelled, we would then work forward to all other points that we can reach. So from B we can reach D, which is a total length then of 14, and we can also reach C with a total of 4 plus 3, which is 7. So that becomes a new value on for point C. Now you can cross out the 9. However, do be careful that it can still be read by the examiner. So I'm just going to change it from 9 and put in a new value of 7. So that then is now our smallest value, so that becomes the third point to be labelled and has a value of 7. From there we can reach E, F and D. So taking E first of all at the top, 7 plus 3 gives us 10, so a new value there of 10. 7 plus 14 gives us 21 for F. And then 7 plus 2 gives us 9 for D. The smallest one of those is D, so that gives us our fourth point to be labelled with a final value of 9. Going forward from that point, the 9, to H, 9 plus 16 gives us 25. And 9 plus 10 is 19 for F. The smallest ones now with their temporary labels is E, so that becomes the fifth point to be labelled and its final value 10. From that point we can reach G, so that gives a value of 14 for G. We can also reach F, and that will give us a new value of 18 for F. Looking at those, we've got the smallest value of 14 for G, so that becomes the sixth point and has a value of 14. From G we can reach H with a value of 14 plus 8 is 22. We can also come back to F. 14 plus 3 is 17, so I've not quite room on my diagram to get that. So 17 comes in there, and that becomes the next point to be labelled, 7th, with a value of 17. So we're then left with one final point to become labelled. So from F we can reach H. 17 plus 4 is 21. So we get that to be the 8th value and 21. The shortest distance from A to H is then equal to 21. And the shortest route, while working through our diagram, let's take another pen, we're going from H working backwards and looking for values from 21, which taking away the values on the route to give us the value in the previous box. So if we work back from H to F, you can see that 21 take away 4 is 17. So this becomes part of our shortest route. If we look at the other one from F, 21 take away 8 here, that would be less than the 14, so this is not part of our shortest route. And also if we go from the 21 take away the 16, that isn't equal to 9. So we've got the 21 minus 4 is 17. Working back in the same sort of way, 17 take away 3 there to G, and then 14 take away 4 gives us the 10 at E, and then we go to the point C, and then from C to B, and finally back to A. So our shortest route is as follows. It's A, B, C, E, G, F, H. A to B, then C, E, G, F, H. Now we want us then in the final part of the question to write down the shortest route from H to C and find its length. Well, C and H are already on our shortest path from A to H. So there's something called Bellman's principle, which says that that must then be the shortest route from H to C. So our route will be H, F, G, E, C, and it will be a length of, well, we can take the value at C is 7 and the value at H is 21, so it's 21 minus 7, which is 14. You don't actually need to go through the route again, you simply look at the values that we've got in the previous question in our diagram. The marking for this part of the question then, or these parts of the question, there was an M1 mark as long as we saw some replacement of values, those temporary working labels changing. And then there were a series of A marks depending on how far through you got through the question. So for the first 3 points A, B and C correct, there was A1, there was another A1 mark for D, E and G correct, and finally an A1 mark for F and H. So that would be looking for all of those values to be correct, all of the numbers in the boxes, including those changing working values, to show that you'd used the algorithm correctly. The shortest distance, 21, was an A mark, and then a B mark for stating the route, and 2 B marks, one for the route from H to C and another one for stating its length. So that's the solution to that question finished. You can find solutions to other questions at www.furthermaths.org.uk.